Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 290. Page 290, problem number 157. And today is our lesson number 218. 157, it says, if n is a positive integer and k equals 5.1 times 10 raised to n, the question is, what is the value of k? Let's see what they tell us in the first statement. In the first statement they tell us that k, whatever it is between 6,000 and 500,000. Well, that's very straightforward and simple. The question is, what's the value of k? N is a positive integer. What's the value of k? In order for us to figure out the value of k, somehow we have to figure out the value of n. We have to find what value of n would work in such a way that the k falls within the allowable range. That's all it is. So ask yourself, can n be 1? 5.1 times 10 raised to 1 is just 10 raised to 1 is 10. 10 times 5.1 is 51. 51 does not fall into that range. This is the value of k. K equals 5.1 times n. Can n be 1? The answer is no. N cannot be 1. Let's ask the next question. Can n be 2? Had it been 2, this would simply be 5.1 times 100. 5.1 times 100 is simply 510. 510 does not fall in this range. N cannot be 2. Can n be 3? Well, let's find out. If n were 3, 10 raised to 3 is 1,000, and it's... I think I made a mistake before. 5.1 times 2 is not 510, it is 51. Last time it was 51 when n is equal to 2. When n is equal to 3, it's not going to be 51,000, I just realized. It's not going to be 51,000. It would have been 51,000 had it been 51 times 1,000. It's 510. When n is 3, k would be 510, which is not allowed here. K has to be more than 6,000, n cannot be 3. Can n be 4? Well, let's find out. Had it been 4, it will be 5.1 times 10,000. 5.1 times 10,000, and that will give you 51,000. 51,000. Does that work? We are told that k, whatever it is between 6,000 and 500,000. Well, 51,000 works. It is possible for k to be 51,000 because it falls between 6,000 and 500,000. N can be 4. N can be 4. Let's continue. Can n be 5? Had it been 5, we would have had 5.1 times 10 raised to 5, which would be same as 5.1 times 100,000. We need 5 zeros. 100,000. We're going to end up using 1 0, 1 decimal place to move this decimal point to here. So it will be 51 times, instead of 100,000, it will be 10,000, and we'll end up at 510,000. Is that allowed? Can k be 510,000? The answer is no. K cannot be more than k cannot be 510,000 because k has to be less than 500,000. K, we are told, is between 6,000 and 500,000. So there you have it. N cannot be 1, 2, or 3. N cannot be 1, 2, or 3. And N cannot be more than 4. Well, if it cannot be more than 4 and cannot be 1, 2, 3, it has to be 4. It has to be 4, and if n is 4, k equals 51,000. The question was, what's the value of k? The value of k is 51,000. The first statement does the job. First statement does the job beautifully. A, D, B, C, E. Because the first statement by itself works, we know now that the answer cannot be B, C, or E. It will have to be either A or a D. Let's look at second statement, shall we? Let's see what they tell us in the second statement. In the second statement, they tell us, number 157 was it? K squared equals, well, this is too simple. K squared equals 2.601 times 10 to the 9th. Oh, this is too silly. The question is, what's the value of k? The value of k, you just take the square root of both sides. And that will give you your k. K equals square root of this, whatever that is. And we don't have to waste our time to actually figure it out what it is, because they're not asking us what is the value of k. The question here is, even though that's what it says, what's the value of k, but we have to always keep in mind, we have to always keep in mind that these questions are called data sufficiency. Even though it says what's the value of k, it doesn't mean that we actually have to find the value of k. We just simply have to figure out whether or not we have sufficient data to be able to answer the question. And of course we do. This is the value of k. Value of k, what's the value of k? The value of k is square root of 2.601 times 10 raised to 9. There you go. Second statement does the job. Therefore the answer is, the first statement was also sufficient. Since the first statement was also sufficient and we found out the second statement by itself also does the job, the answer is D. That's it. What we're going to do now, as far as the exam is concerned, we are done. What we're going to do now is actually understand how to figure it out if we had to. So very first thing we have to understand is 2.601, there are 3 decimal places, 1, 2, 3. So if we were to multiply it by 1,000, we can get rid of the decimal places. If we multiply by 1,000, we use up 3 zeros, so here we are left with 10 raised to 6. We need to take a square root of that, which is same as square root of 2,601 times 10 raised to 6. Which of course is same as square root of 2,601 times the square root of 10 raised to 6. The square root of 10 raised to 6 is just 10 raised to 3. What about square root of 2,601, which is what I want you to understand very quickly. You see, there are some basic facts in arithmetic that you must have at your fingertip, as I always remind you, and they come in very handy. You must know the popular squares. You must know your squares 1 through 20, with the exception of maybe 17, 18, and 19. You should know all the squares by heart, 1 through 20. You should also know the square of 20. You should know, which is 400. We should also know a square of 25. It comes in very handy. Square of 25 is 625. These are some things that you just have to know so that you don't have to waste your precious time during the exam. And they, as I said already, they come in very handy. Like for example here, in order for us to figure out what square root of 2,601 is, it comes in very handy to understand the square of 50. The square of 50 is simply 50 times 50 is same as 5 times 5, which is 25, and the 2 zeros is 2,500. This is not 2,500, this is 2,600, 2,601. So let's try, instead of 25, let's try 26. Or rather, I don't mean 25. Instead of 50, let's try 51. 51 times 51 and see what it works out to be. I'm very optimistic that it will be 2,601 for only one reason. If you were to multiply 51 times 51, the unit digit would have to be 1 times 1, which is 1 here. So it matches, the unit digit matches, which is actually a good sign. So let's do it then. 1 times 51 is just 51, 5 times 1 is 5, and 5 times 5 is 25, and we get 1, 0, 6, voila. So there you go. It is 51. So the question was, what's the value of k? The answer is, the value of k is 51,000. Just like what we found in the first statement. This should not be a surprise to us. In the first statement we found that the value of k was 51,000. They never contradict each other. And therefore second statement by itself is also enough. Not therefore, I shouldn't say therefore, we don't have to do all this work to figure that part out. We figured that out a long time ago. It's just a matter of doing it out. The answer is D. Alright? Bye now.